Hello and welcome to the first official live stream by Maths and Science 8. So in this video or live stream, we are going to be talking about this question about Newton's second law of motion. By the way, this is from the Gauteng preparatory exam for 2023. So the question goes as follows. Okay, yeah. So the question goes as follows. Two blocks are attached to each other by a light inextensible string moving over a frictionless pulley as shown in the diagram below. The slope AB has a smooth surface and makes an angle of 50 degrees with the horizontal. The slope BC has a rough surface and makes an angle of 30 degrees with the horizontal. And here is the diagram depicting all that scenario. 2.1 State Newton's second law of motion in words. And I'm sure that you can agree with me that this is pretty much straightforward. Now, 2.2 says the coefficient of kinetic friction between slope BC and the block M2 is 0.2, as we were told that the slope BC has a rough surface. So this meant that there is friction. So it's not a surprise that they are giving us the coefficient of kinetic friction. Now, 2.2.1 says draw a labeled free body diagram for block M2. So let us do exactly that. So for our free body diagram, we will draw a dot to represent the block. And as usual, we know that we have a gravitational force, or in other words, weight, which is acting directly downwards. And then the surface will exert a normal force on the block, which is always perpendicular to the surface. And then there is a tension force that will act up the plane due to the light inextensible string. And then that surface is rough, so this means that there is also a friction, and it will also act up the plane because friction always opposes the motion of the object. And so these should be all the forces acting on block M2. And we can confirm that we have indicated all the forces by looking, at the number of marks for this question. So this is for 4 marks, and as we can see, we've got 1, 2, 3, 4 forces. So all is good. Now, alternatively, this is what you can do. Instead of showing the weight force, you can just show its components, okay? And we know that this weight force, since this is an inclined plane, it will have a perpendicular component, right? And we call that a perpendicular component because it's perpendicular to the surface. And then we also have got a parallel component, which is the component of the weight that is parallel to the surface. And this is always acting down the slope. So the weight parallel is always down the slope. But what I like to do is I like showing that weight parallel here instead. So alternatively, you can show it there. The advantage of doing that is you now have got this right angled triangle because that angle is 90 degrees. And now this angle here will be equal to 30 degrees, that slope of the plane, okay? And now the advantage of this is when you are working out the expressions for the perpendicular component and the parallel component of the weight, which we are most definitely going to need as we are going through the next question. And the next question says, calculate the magnitude of the acceleration of the system. Show all steps in your calculation. So we want the magnitude of the acceleration of the system. And like I said, this is about Newton's second law of motion, which is obviously why they asked you to state it in 2.1. So to answer 2.2.2, we know that Newton's second law says F net is equal to ma. Now, how we are going to approach the problem is we can simply apply Newton's second law of motion in each of these blocks separately, and then solve the two equations that we get simultaneously. So let us start with block M2 since we have already drawn its free body diagram. So for block M2, and we must indicate the positive direction. So let us just say down the slope BC is our positive direction. Now, we can see that the forces that will contribute to the net force are the parallel component of the weight, the tension force, as well as the kinetic friction. So these should be equal to ma. Now, as I had already said, we now need to determine the parallel component of the weight. And if we go into this diagram here, we can see that the parallel component is opposite, is an opposite side in this right angled triangle. So opposite, while the weight force itself is a hypotenuse side. So opposite over hypotenuse is sine, meaning that we can say that the parallel component will be given by the weight multiplied by sine of 30 degrees. And then we do not know the tension force. For the frictional force, we can be able to work out its magnitude, because we know that the kinetic friction is equal to the normal force multiplied by the coefficient. However, we need to work out the magnitude of the normal force. This will be obviously equal to the perpendicular component of the weight, because the normal force here and the perpendicular component are at equilibrium. So the normal force isn't just going to be simply equal to mg in this case, but it will be equal to the perpendicular component. Now, we know that the parallel component is given by the weight sine of theta. Then it is given that the perpendicular component will be given by the weight cosine of 30 degrees. Okay? And alternatively, we can also see that this perpendicular component is adjacent to this angle of 30 degrees. So adjacent over the hypotenuse is equal to cosine. Okay, so these are going to be equal to ma. Now, we must actually be mindful at this point already about the signs of these forces based on our direction that we have chosen. For an example, we say that the parallel component of the weight is acting down the slope. So down the slope is our positive direction. However, Ft here is acting up the slope. So we can give it a negative sign. And even the frictional force, in fact, I'm making a mistake here. So remember, the normal force must be multiplied by the coefficient of kinetic friction. But now the frictional force is acting up the slope, so let us just give this a negative. So these should be equal to ma. So that is very important. I was making a mistake by leaving or not considering the signs. Now we can plug in the values. The weight is equal to mg and the mass of M2 is 70, g is 9,8. So we multiply that by sine of 30. So minus Ft and also minus mg, which is 70 multiplied by 9,8 multiplied by cosine of 30, and our coefficient is 0.2, and so this should be equal to the mass, which is 70 multiplied by the acceleration of the system. And now what we need to do is we need to take out a calculator in order to simplify this equation. Okay, so we've got 70 multiplied by 9,8 multiplied by sine of 30. So this is equal to 343. And then minus Ft. And now let's work out that term. So this is 70 multiplied by 9,8 multiplied by cos of 30 multiplied by 0.2. And this is equal to 118,82 if we round to 2 decimal places. So that is equal to 78. Now let us add up our like terms. So 118.82 plus 343. So that is equal to 461.82 minus Ft is equal to 78. So now here is the thing. I'm gonna suggest that we make Ft the subject of the formula here. So if we do that, we are gonna get, okay, first negative Ft will be 70A minus 461.02. And now we can multiply by negative throughout this equation to get Ft is equal to negative 70A plus 461.02. So let us call this our equation 1. Now, making Ft the subject of the formula will be an advantage here, because now the next step will be to do the exact same thing but for block M1. And in the equation that we get for block M1, we will simply substitute in the expression of Ft, or equation number 1, in order to get the magnitude of the acceleration of the system. So let us do exactly that. But before we can be able to do that, or before we do that, it's advisable that we do the free body diagram for M1 as well, although we're not asked in the question. So let us do it here, even if it's just a force diagram. So that's our normal force. That is the weight. And then what else do we have? It's the tension, of course. And then we're told that AB has a smooth surface, meaning that there's no friction in this case. And then likewise, we've got the perpendicular component of the weight, and we also have got the parallel component of the weight. Remember, the parallel component is always in the direction that is down the slope, okay? And so this angle will be 50 degrees. So now we're in a good position to apply Newton's second law for block M1. So for block M1, we can see that our net force will be given by Ft plus the parallel component equal to MA. But even here, note that actually Since we had chosen down the slope BC as our positive direction, for block M1, our positive direction must be up the slope. Because we have chosen this as our positive direction, then up the slope should be our positive direction along AB. And that is because these two blocks are going to move as a system. So they will move together. So the direction that we have chosen in our first part of the problem will determine the positive direction for the second part, which is block M1. So if that's the case, it means that Ft is going to be positive, but the parallel component of the weight is actually going to be negative. Okay? And so we still do not know Ft, but now we can be able to calculate the parallel component of the weight. And obviously, even in this case, this will be given by the weight, which is mg. So I'm not going to make this long. I'll get into the substitution already. We know that M1 is 12 kilograms. So this will be 12 multiplied by 9,8. And so the parallel component, again, if you want to confirm the expression, we can see that the parallel component is an opposite in this triangle. So opposite over hypotenuse is sine. So we will multiply this by sine of 50 degrees. So equal to 12a. Okay? And so now we can again just simplify this using our calculator. Okay, so this time around we've got 12 multiplied by 9,8 multiplied by the sine, this time around of 50 degrees. And that will be equal to 90.09. So here we've got Ft minus 90.09 equal to 12a. Now, at this point, we do not even have to manipulate this equation further. So let's just call it equation number 2. Now, what we are going to do is we are going to substitute equation number 1 into equation number 2. And we can see what equation number 1 is. So in place of Ft, we are now going to write 70a, in fact, negative 70a plus 461.02. So that is our Ft. And it's advisable, when substituting an expression to put it inside brackets, just in case, the signs will be affected when you are multiplying, especially if there was a negative sign here. But of course, in this case, there's no need to do that. And then we can subtract 90.09, and yeah, this will be equal to 12a. I hope I'm not making any mistake. So yeah, from here on, you can then just simplify this equation by adding up the like terms and then just solve for the acceleration straight away. And so I'll just leave the problem here for you to complete it. You can continue from here. And then as you can see, there's also 2.3 here, which is the final part of the question. Now, this part says if the angle of the slope BC is decreased. So imagine that you are now decreasing the angle of the slope BC. So I want us to be able to see the original diagram. So if you are decreasing that slope to 20 degrees, will the frictional force between the block and the slope increase, decrease, or remain the same? Explain the answer. Note, no calculations are needed. Okay, so the question is, will the frictional force between the block and the slope increase, decrease, or remain the same? So if we decrease the angle of the slope BC, how is the frictional force going to be affected? So this is very straightforward. Remember that, as we had already done, when we're applying Newton's second law for BC, we know that the kinetic friction is equal to the normal force multiplied by the coefficient of kinetic friction. And remember that since this is an inclined plane, we said that the normal force would be equal to what? To the parallel component of the weight. I mean, the perpendicular component rather of the weight. And now, if you decrease that angle to 20 degrees, what is going to happen? Well, it turns out that what happens is the magnitude of the perpendicular component is going to increase. And how you can think of it is that the steepness of the slope will decrease. Imagine you had a slope that is this steep, and then you decrease the steepness into this. If you've got an object that is there on this surface, and then you compare it to an object that is on this surface, even if it's still the same object, obviously this one is most likely to slide, and it will slide very faster compared to this one. And the reason for that is because here there is more friction than here, and that is due to an increase in the perpendicular component of the weight. Oh, oops, I did not know that my calculator, I forgot to turn it off. Ish. But I hope that you got, what I was saying. This is the diagram I was talking about. I'm sorry about that. So you see here, we have an object, this red dot lying on this surface. And then here we've got an object, this blue dot lying on this surface. This one, let's say that is the 20 degrees. And this one, let's say that it's the 30 degrees. As you can see, the red ball is lying on a much more steeper surface compared to the blue dot. So obviously this one is experiencing a more gravitational pull due to the parallel component, compared to this one. But this one has got a bigger component of the, perpendicular component compared to this one. So all in all, because of this increase in the perpendicular component of the weight, if you decrease the angle, then there will be more frictional force. As a result, to answer this question, yeah, they wanted to know whether what will happen with the frictional force. So the frictional force will increase due to the increase in the perpendicular component of the weight. And you can even prove this mathematically. Remember that we said the perpendicular component of the weight can be given by 70 multiplied by 9.8 multiplied by the cosine, and initially the angle was 30 degrees. So you see, we get 594 as our perpendicular component. Now if you change that to 20 degrees, what do you get? 644. The magnitude of the perpendicular component has increased. So this will cause an increase in the frictional force. So I hope you get it. That is all, for today's live stream. If you found it helpful, please do like, the video, press that like button, and please comment below if you'd like to give me some feedback, or if you've got any question, or maybe if you want to point out a mistake that I have done, because I'm only a human, so I can also make mistakes. Otherwise, that is it for today. I hope to see you on the next one. Goodbye.